of LeetCode. 1,000 days of LeetCode. Gotta relax though. It's actually only day 100, so you've got a lot more work to do. But it's been a long road. I'm out of breath. after 100 days of LeetCode, we need to do 100 days of cardio. So that's going to be on the next channel. It's going to start on the next channel. I also got some feedback that the mic was a little too low. Right? But what a time to be alive. Don't want to celebrate too much. 100 days. I mean, yeah, I haven't been able to do anything long term, so this kind of an achievement. But yeah, on day 200, we're gonna get sturdy. So you're gonna want to be subscribed to that, because we're gonna be getting sturdy on day 200. So make sure you subscribe to that. Also, make sure. Okay, this music's gotta go. Actually, it's gotta stay. I'm gonna want to make sure that you're in the hyperbolic coding chamber for this day. Day 200, we're all gonna get together and we're gonna get sturdy. Okay, so you're gonna want to be there for that. But we have another day of grinding to be done. 100 days. I mean, I was looking earlier at the beginning videos. Look at this sad old chap here. Actually, I have to gotta remove all this. Look at this sad old chap. Yeah. I was doing day 1. It wasn't really day 1, because if you actually check the description of this video, it's actually day 74 at this time. But at this point, I was doing about 15 minutes a day or something like that. And I was like day 74 doing 15 minutes a day. But yeah, you can tell that I want to die. And yeah, I think for the first 60 or so days, you can just tell that I want to die. Then after that, it became much simpler. So here we are. I'm going to be releasing. We also got a lot of W comments yesterday. Just people coming through. We got the online gamer. What 100 days? Oh yeah, I'm going to be making a video called "What LeetCode Taught Me," or 100 days of LeetCode. I have to do the game. I have to play the game. I'm going to be making the video. It's going to look a little strange because I'm going to be in the thumbnail. I'm going to be very, but it's hard. You got to do what you got to do. And yeah, I always think it's funny because I think you got to get into a certain mindset. You got to get into like a certain mindset to, or at least I have to get into a mindset to do these videos. So it's a much more like pared down version of my personality, just because I'm trying to stay focused. So it tends to mute me a little bit. But yeah, it's just interesting because when I look back on the videos, I feel like if you know me in real life and then you watch these videos, you're probably thinking like, whoa, like, who is this man? Because I watch the videos and I think that. But yeah, it's just interesting to see, because I think it's just, yeah. But W, let's go. You are a genius. I actually may use this title. Maybe we have to wait one more day. God, Lord, good Lord, we are so close to 100. I admire you, brother. W, man. Awesome support, man. I didn't expect so many comments on before day 100. So yeah, I woke up to that and that was pretty cool. Love the consistency, dude. Love the profile picture. You look through it on terms of the. That's yeah. It just feels good, man. Just feels good, man. Yeah, so I think after LeetCode, you do all the Euler project questions, I assume. So I actually looked at Euler project, and I'd never heard of it before, but it's like a LeetCode V2. So there's a lot of, it seems like, honestly, I was reading the About page, and it seems harder than LeetCode. I'm going to be honest. It just seems harder. So, Yeah, I think after that, after LeetCode, we'll just do that. I don't see why not. But I'm sure I'll have another. I'm sure by the time we get there, I'm assuming that this process might speed up. I don't think it'll take us forever to finish the problems. In fact, there are already people on LeetCode who have finished the problems. So I think it's just about documenting it. Now it'd just be something cool to have. So I wonder if we'll have another project afterwards that might be cool or interesting to see or do. Because I just would like to finish working on the list that I have in mind. But yeah. So yeah, I don't have many. I was going to say a bunch of stuff just because it's not that big of an achievement because it's just 100 days. But yeah, I think it's just, for me, I haven't like been able to do many things consistently ever in my existence on this floating rock. So the fact that we could make it to day 100 was just pretty cool to see. So anything I do have to say, I have to make a clickbaity / fluffy. Actually, I'll try to make the video not fluffy, but it's going to be like 100 days of LeetCode or something like that. So yeah, I'll try to make it not fluffy because I think a lot of videos nowadays tend to be like really fluffy, but maybe that's part of the game. You can't knock it. So I don't know. Well, I'll try and put as much useful stuff as I can in there, but it's just stuff that I did, so I don't know how useful it'll be. So we shall see. When we we still have a long way to go. And I remember there's an episode from Andrew Huberman, the buffest scientist on the internet. He tells a story about, I think I'm gonna butcher the details here, but he tells a story about how I think he's working with. Maybe he was in his PhD program, and I think they were finishing up some large bit of research, and he was working under maybe a professor or maybe like someone higher up at the time, and they just finished this really successful paper, and I think his first idea was like, oh, we have to like throw a party and like we have to celebrate, and then I think his professor, or I forgot who it was, but they were just like, can't celebrate too much. And I think what they were saying was that they weren't going to celebrate too much. They were going to throw like you could throw the party and everything, but during the party you kind of had to be like mellow or checked in or sort of like, you know, mellowed out. And I think that was because I think it's pretty much, I mean, if you watch Andrew Huberman, there's a lot of stuff about the limbic system and dopamine and stuff like that. And I personally think what he was trying to get at, my interpretation of it, was that when you have something that's like, you know, you're expecting this big dopamine rush, right? And you get it, there's like a decline afterwards. And there's also an expectation, right? So if you do something really, really cool, at least to yourself, you get like this huge rush of doing it. And then you might be expecting that in the future. And then instead of working for the sake of the thing, you end up working for the hit. But I'm pretty sure the way it all works is that the hit just, it never is quite the same. Like the first time you try a bite of pizza, it's just never the same as the 1,000th bite. Or the first time you get a phone, or your first kiss. Like, it's all of this stuff is just never the same as the first time. So I think we can't celebrate too much. Otherwise, we'll mess up the reward process. And it also makes me think of this book I was reading called Never Enough. I think it's by Judith Grisel, but it's basically just about dopamine addiction and all these reward pathways. And there's also a bit where she talks about opponent process theory. And I'm going to butcher this right now. So if it sounds like it's cool, you should look it up and learn it from someone who actually understands it. But I'm just a regular dude reading the book, so I'm going to say what I kind of took from it. But basically the way I understand it is you have an A process, which is, you know, something you're enjoying, something like a rewarding process. If you imagine like a graph, your enjoyment is going up, right? But there's also, your brain has a response called like a B process, which they usually call the B process. And this is supposed to dampen that A process so that you remain at the baseline, because the goal, even outside of the brain, I guess, and in the mind and the body and stuff like that, is just homeostasis. So, you know, like temperature, like you're never too hot or too cold if your body can help it at least. And I think the brain is what they're trying to get at, is the brain is the same way. So if you experience a large dopamine like mountaintop, right, inevitably there is always a down. So I can relate to this because I remember anytime I went on a vacation with family, or anytime I enjoyed something, even if nothing bad happened afterwards, you would just always feel a little bit empty, right? So I don't know if you guys, if anyone can relate, but maybe after a break or something, you know, you're coming down the cliff and you're just like, I just had a great vacation. Why do I feel so mellow? And I think it's just the B process, like bringing you down back to baseline. Because if you're not at baseline, you actually can't tell whether things are bad or good. And the book talks all about how if you're always up high, where suffering, the line of suffering is, actually raises as well. So if your baseline is here and you're always riding this cliff up here, the requirements to get that high get harder every time, and then the B process gets stronger every time. So even though your baseline should be here, regular existence, as you abuse your A process, the B process is that you go lower and lower. So now your day-to-day might be down here, which is literally suffering. And then a lot of people who suffer with addiction have, I think, or seem to have like a similar, or theorize a similar effect happening. So that's why, like, I think in the book she also writes, people think, I think in the book she writes that like people basically, I think she writes like people that are going through these things are actually using to be free from suffering, because that lower bar just takes you, that B process takes you all the way down and lower, whereas your baseline would be here, and now your baseline's like all the way down here. All of that to say, it can be reversed. It can be reversed. So if you make your A process struggle, for example, doing something difficult, your A process will be struggle. And the same thing, I think to some degree, your A process, or your since if your A process is struggle, then your B process could be pleasure or celebratory or something like that. And I definitely feel like that could be something. So after I do something difficult, like actually difficult, not just something I hate, but something actually hard, there's always a bit of like, and I think computer science can definitely be like that. Working on programming problems is definitely like that, where you finish the problem, like you hyper focus on a problem, work on it for like 12 hours, and you finally finish it, and then you're just like, now I can relax. So feels strong, man. All that to say, the dopamine hit at 1,000 days is going to be crazy, or maybe it won't be. Maybe, yeah. So I'm just going off the top, so it's not really organized. So that being said, we have a long ways to go, and this really is just hopefully just the beginning. Can't get too comfortable. It's been difficult to maintain this. So we shall see. Maybe this is the last video I'll ever upload. I hope not. So yeah, gotta stay focused. But yeah, I hope you were dancing too as well. So we shall see. And yeah, I'm actually running really short on time. So we're going to jump straight into this. Thanks for all the comments. That was really cool. I didn't expect to find those. So that was pretty cool. And yeah, we're going to jump into LeetCode. We weren't doing very good because of a specific problem. So I think we could figure this problem out, but we ended up having some difficulties. So I think because we ran out of time, we tried to solve this in 7 minutes. We just didn't have the time. So we're just going to do it. And then, yeah, we'll do this one to keep working through the remaining easy problems. So we're just going to jump into it. Also, make sure you're in the hyperbolic coding chamber. A lot of cool new people joined recently. And yeah, we're just talking shop. And, you know, you're going to want to join for the special code. It's a special code you can type that's going to spawn an instance of GPT-3. So you're going to make sure to join that. And yeah, let's just jump into it. So the problem was called strobogrammatic number. Given a string num, let me make sure everything is lined up correctly. Given a string num, which represents an integer, it's a little confusing. Return true if num is a strobogrammatic number. A strobogrammatic number is a number that looks the same when rotated 180 degrees. So you had num 69. If you rotate it, 6 and 9 kind of swap. And so it is the same upside down and regular ways up. 88 is the same. And 962 gives us false. The string is always at least one character long. It only consists of digits and doesn't contain any leading zeros except for 0 itself. So I think what we went about, we listed all the numbers from 1 to 9, and then we figured out which ones, no matter which way you flip them up and down, they're definitely not the same right side up. One of those numbers we forgot to count was technically 3, because if you flip 3, it actually swaps direction, so that's actually not one of the numbers. But 1, if you depending on how you write it without serif, I think it's interchangeable, and I think we can test if this problem believes that that's true if we just run it. Yeah, so 1 is interchangeable up and down, it seems like. 6 is a star because it can be replaced with 9. 8 is the same as 1. 0 is the same as 1 and 8. And I think our solution was to create a map of values where the key would actually be the string as a number, and then the value would actually be an array of the indices where it occurs at. And I think that's where we started to fall apart. So while we're creating the map, if we run into any of these letters that are not strobogrammatic by default, we'll just return false, and we could abstract this out to, like a map or something, so that we don't have to do this long if. But down here is where I think our logic got a little bit messed up. There's a 6 array, right, and potentially a 9 array. And I think that's where we got messed up. Whichever exist, or both, they have to match up. And that's where this gets very confusing. So let's imagine if we had something like 6, 6, and 9, 9. If you flip this over, you get 9, 9, and 6, 6. Which is not the same. Oh no, I keep messing up. If you flip it upside down, you would actually get 6, 6, 9, 9. So in another way, what we're checking is that do all the indexes of the 6s, all IDXs of 6, map to 9? I think that only works when both the 6 array and a 9 array exist. Indexes of 6 map. All indexes of 6 map to 9. All indexes of 6 map to 9. We check if all indexes of 6 map to 9. All indexes of 6 map to 9. All indexes of 6 map to 9. It's 6, 6, 9, 9. Yeah, all indexes of 6 have to map to 9. 6, 6. Let me check something. If we put in 6, we should get false. Oh, I think that's if any of these don't exist, then we want to return true. I mean, we want to return false, actually. Yeah, what was I trying to write with this? But 6 is not strobogrammatic, which makes sense. 6 is not strobogrammatic. So what was I? Strobogrammatic. So if the 6 array doesn't exist or the 9 array doesn't exist, because if 6 and 9, if we need at least both of the pairings to exist. So if one of them doesn't exist, the string can't be strobogrammatic, which means if we have a 6, we must have a 9. So let's just check if that's true. If we have a 6, we must have a 9, because if you flip 6 180 degrees, you get 9. And so it only works if you have a 6 and a 9. Let's just say you have 6 and a 9. If you flip it around 90 degrees, you still get 69. Now, if you had 96, this does actually still give you 96. But we need a perfect mapping of 6s to 9. So if the lengths aren't the same, we also return false. And then what we're doing here, we check 9r's length, which is 1, minus I, which is 0, and we get the index of the 9 at this particular we get the index of the 9 in the string, and then we check if it does not equal 9. That doesn't make sense, because it should be, if we do 9R, we'll get index 1, num sub 1 would be equal to 9. want to make sure that 6 from, or basically if you flip it around, we want to make sure that 6 from earlier, that 6 from earlier now maps to a 9. That 6 from earlier now maps to a 9. Which would mean we would want (6R) if it doesn't equal 9, then we would return false. So 6R, we'd get 6R dot length, which is 1 minus 0. 6R dot length minus 1, which is it's an array of length 1. Oh no, it's an array of length 1, so it's 1 minus 1, which gives you 0 minus 0, which is 0. So we know that the 6 is at index 0. The 6 is at index 0. The character at that index would be 6. Basically what I'm trying to get at is if we have a 6 at the first element, if we flip it around, we should be able to check that index from the other half of the array, and it should be equal to a 9. Which is why we did 9R. Okay. No, but what were you? Oh yeah, it's the sub part. If we check the, now if we were to check the 0th index in 9 array, we would get 9. If it doesn't equal 9, we'll return false. So I think this one works. Let's try it with 69. This does work for 69 somehow. Let's try it with the test cases. There's one more case, right? I think we're only failing one case, and the case is 88. It's 88 because I wrote if not 6R and not 9R, return false. I think what we might need is both. Because if they both don't exist, if they both don't exist and we return true, well, that's what we had it as before, but then we ended up failing a different case where if they both don't exist, not 6R and not 9R. Oh, we also had an and before. I wanted to catch basically if one of them doesn't exist. Which I think what we need to do is we have some cases that we need to mix together. if they both exist, I still want to use them. So if 6R and 9R if they both exist, we want to do work on them. And then if either one of them doesn't exist, we want to return true. The problem being that if they both exist and we run this one first, or if they both don't exist, we want to return true. Right. So if they both exist, we want to do work. And if they both now we can have it like this. If 6R or I see what's caps lock, please. Right, we have a couple cases here. If one of them doesn't exist, we want to return false. We can only safely do that first if we check that both of them don't exist. Now, if both of them don't exist, that's true because it's okay for you not to have a 9 or a 6. But the other problem is, right, if they both exist, and this is a mess, if they both exist, we just want to be able to do regular work on them. So maybe we can drag all this. I wonder why this is all so hard to read. So we have if 6R and 9R do work, right? If it turns out, we might return false. If we did this and they both exist, well, if we didn't do this, it means one of them doesn't exist. Well, if they both don't exist, it's okay, return true. Now, if just one of them doesn't exist, return false. And I think one of the things we can do before all of this no, wait, it actually fixed the test cases. So let's try and submit it. So our output for this one is maybe I'm overthinking this. I think I got confused yesterday when I was prototyping this problem. I think I conflated reversal and rotation. Now I'm thinking there's a simpler solution. I think all you have to do is reverse the string. So instead of the work, I think the work I'm doing up here up there is important, because some letters just aren't strobogrammatic. But then I think afterwards, instead of doing this check here, I think you can just reverse the string. If you reverse the string and then turn all the 6s into 9s, it should be the same if it's the same. If the strings are the same. So if I took, like we had 69 and 96, reverse the string, you get 96. And then I turn the 9s to 6s and the 6s to 9s, you get 69. Same here for this. You get 69, turns to 6 to 9s, and the 9s to 6s, you get 96. When you have strings like 10 and 0, 10, if you rotate it like they said, you get 0, 1. I think if you reverse the string and it's not the same string, well, let's try that. Which would kind of, it's fine, I think. We'll just say, want to reverse the string. We'll just destructure num into an array. Let right equal no s dot length minus 1, and then we'll say while left is less than right, then we're just going to reverse the string. So we'll save the temporary value of s sub left. So we're going to replace s sub left with s sub right. And s sub right gets the value of temp, and then we can do left plus equal 1, right minus equal 1. So if you reverse it now, we'll also do the transcription of 6s to 9s. We'll say s sub left equals 6, then we'll set it equal to 9. Otherwise, we'll give it the value of s sub left. So if s sub left is equal to 6, change its value to 9. Otherwise, let it have its normal value, and then we'll duplicate this for right car. Wait a second. Yeah, this is not going to work. We'll just have one more iteration through. Or we'll just do for I equals 0, I is less than s dot length, I equals plus, and we'll just say if s sub I we'll say, actually we'll do what we did doing before. So if the current string is equal to 6 or 9, then what we're going to do is swap its values. So s sub I equals s sub I equals 6, and we want to change it to 9. Otherwise, you want to change it to 6, because it would mean that it's 9 if it doesn't exist. And then I think if we console.log s, we should get an array. So the array we get is 6, 9, which I think means we're reversing it properly. But let's just remove all these test cases and do 1, 0. I think they were missing, we forgot to take our bracket. All right, and then I think we can just check if the strings are the same. So let's say return dot join with no spaces if it equals num. And then let me fix the spacing on this. Okay. I don't want to delete the code yet. We'll see. Let's try it for all the test cases. Somehow this came out of nowhere. Works for these. I see. Yeah, I think we overthought the rotation. Or maybe I take the words too literally sometimes. Let me see if we can optimize this. I don't think we need to do the map portion because we wanted to say, hey, if the letter or the number includes 2, 4, 5, if the string of numbers includes 2, 4, 5, 7, or 3, we want to return false. And we did that in a map. I think this algorithm is just 3n, which is just n. We can save space by not having to use. We're not really using any space anyway. We use a map, but if the string can only contain digits, then we'd only have at max 10 keys in the map. So there's 10 symbols in base 10. But we do use a string that can be up to length n. Maybe it would be linear time and linear space, where n is the number of characters in the string. But we can make it slightly faster. Except I'll keep that bit. We could always have taken this part out, or made this part simpler by just using a map. So we could just say disallowed dot get letter, and if it exists, then we'll just return false. We're just going to use a bunch of ors together. Oh, cannot find letter. We'll just say const letter equals s sub I. And we'll place all s sub So maybe that. Well, it's about the same speed. But yeah. So they're saying a big part of this problem is clarifying the requirements, which is a good point. Rotating number by 180 degrees. A good first step is to think carefully about what it means to rotate a number by 180 degrees. So they did the same thing, so they just went in reverse. That's pretty cool. If not rotated, where is this rotated digits variable coming from? Oh, map character rotated digits equals new hash map of. I see what they're getting at here. So they iterate from the left and the right hand side, and if rotated digit does not contain a key for the left character, rotated digits does not contain the key for the left character, or rotated digits that get that's a clever way to save space. That was pretty clever. They're iterating through, since if you rotate it, which should be on the other side, is 6 and 9 are swapped. Which means if we have a 6, we pretty much want it to map to the other side. What they do is they just rotate 6 and we get 9 and check if 9 matches to the other half, the other side of the array. That's pretty cool. That is pretty cool. That is a fun problem. Meeting rooms. So we'll do this one in Ruby, I think. Let's say given an array of meeting time intervals, or intervals, given an array of meeting, I think I know what this might be. Given an array of meeting time intervals, where intervals sub I is equal to start sub I, comma, end sub I, determine if a person could attend all meetings. intervals can be empty. When intervals is empty, does that mean you can attend all meetings? So if you say if intervals dot length 0 return false, or maybe if there's no meetings you can attend them all, or I guess you can't, and we're guaranteed that interval sub I will always have a value that we can use in it, or the minimum, it'll always have exactly the number of values we need within it. So determine if a person could attend all meetings. Maybe it's possible maybe it's possible they're saying, they're not exactly telling us what exactly the numbers within the intervals mean. I don't think they mean hours. Maybe it is the length. So 5, 10, 15, 20, 7, 10. I think what they're basically asking is if none of the intervals overlap. So maybe the intervals don't mean anything, but I think what they're asking is if none of the intervals overlap. That's really the only difference between these two problems. So I think one way we could do this is to sort all the intervals by their starting interval, and then we could just check linearly if none of the intervals, actually no. Oh yeah, well if we sorted them, then we'd have 0, 5, and 15. Then we could check if the end time and the start time were less than the end time of the previous interval. I mean, yeah, if the start and end time of the current interval is less than the end time of the previous interval, then they can't attend all meetings. But let's check this bottom one. If we would assert, we'd have 2, 4, and 7, 10. Right. 10 and 7 are not less than 4, which means that you could attend the meeting. So maybe that's what we'll try. I don't really know how you so sort. I think just say return false, and actually let's check, right, when intervals is empty, if we should return false. So they'd like us to return true if there's no intervals. And then I think what we're gonna do is sort intervals, check cur interval with last interval. So to sort them, we could say intervals dot sort A sub 0 minus B sub 0 2, 4, 2, 10. Oh no, I'm trying to say So I think it is sorted now. We have 2, 4, 7, 10. Something seems a little off about that to me, though. Let me just print it this way really quick. Okay, so we seem to be fine. It is sorted now. Now we're just going to check current interval with the last interval. So to do that, we'll just say start at 0. And you're going to go up until the end of the intervals. And then we're going to have an index. And then here we're going to have end. Right? And all we want to do, we have to also notice that on the first case, our interval isn't going to exist. So if we check the previous interval of the 0th index, it doesn't exist. First thing we want to make sure is that interval, actually what we can just do instead is just start at 1, which saves us the hassle, and we'll just say if, and like we said earlier, if the current interval's start and end value is, either one of them is less than the end of the previous one, they can't attend. So say interval sub interview index sub 1. So if intervals sub interview index, so if the current interval's start index is less than interview index, and then we'll duplicate this line, or if the end of the current interval is less than the end of the last interview index, you want to return false. And then if we make it through all these checks, we'll return true. I think this would give us n log n time, or n log n plus n, which would be n log n. But if we sort these, we have 2, 4, and 7, 10. We'll check if 7 is less than 4. It's not. Is 10 less than 4? No. But if we do this one, if we sort this one, we have 0, 5, and 15. We'll check, hey, is 10 less than 30? Yes. Return false. Let's try the test cases. Yeah, I don't understand why my algorithms are very, very slow. This would be n log n. Is there a linear time solution? Is there a linear time solution? Is there a linear time solution without sorting? Yeah, without sorting, you have to trade space to save, so you can have an understanding of the intervals as you're iterating through it. The problem is that logic gets pretty strange quickly. I think there might actually be a linear time version where the interval is simpler. I think if we just treat it as a problem that asks only of us to keep track of unique numbers. For example, if we consider the range of numbers 0 through 30 as the range of numbers 0 through 30 inclusive, then if any range tries to include its numbers, like 5 to 10, we'd already know that that number exists, which would mean we'd have to return false. If we do it that way, then it could be pretty slow, actually. So I actually think that could be, in the worst case is that every number in the interval is, best case is that every number in the interval ranges, the range in every interval is small. So between 0 and 30 we have 30 numbers, but they say intervals can start and end between 0 and 10 to the 6. So if we had 3 intervals going from 0 to 10 to the 6 minus 1 minus 2 minus 3, we'd actually do like a ridiculous number of operations. So actually, let me see if there's linear time solution. Wow, looks like there may have not been a linear time solution. We have summary ranges. You're given a sorted unique integer array nums. So the array is sorted. Sorted unique integer array nums. So it's sorted and unique. A range AB is the set of all integers from A to B inclusive. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. That is, each element of nums is covered by exactly one of the ranges. There is no integer x such that x is in one of the ranges, but not in nums. Each range. A arrow B if A arrow B if A does not equal B, and A if A equals B. I see. So if it can't be included in a range, it should be printed by itself. And if it is in a range, it should be A arrow B. The numbers are 0, 7. The smallest sorted list of ranges that cover all the numbers in the array exactly is 0 to 2, 4 to 5, and then 7. Ranges are 2 to 4, 6, 8, 9. We have like 2 minutes left. 2 to 3 minutes. All the values of nums are unique. Nums is already sorted in ascending order. I think there's a way to do this with a... What did they want us to output? An array? I think we could do this with an array. For example, if we imagine that we're iterating through this, if we were to push 0 onto an array and then check if the next number is greater than the last number in the array by 1, it isn't, so we just push a new number onto the array, which is 2. Then we could check if 3 is greater than the number we last put in, which would be 2, which it is, so we could put 3 onto the array now. But together, like 2 arrow 3, and then we could check if 4 is 1 greater than the last one on the array, which would be 4, and then 6, and then 8, and then 9. Problem is, how would we edit the array on the fly? Can you edit? I'm just going to check something. If we have a string equals ABC, can you say string sub 2 equals D? And we'll put string. You can. So since we, that makes us a problem though. You know what? We can still do it. It'll be slightly slower, but we can still do it, and then we'll fix it tomorrow. I think what we need is keep running array of numbers of intervals, update previous intervals if is +1 of pre-interval. So we can do this as interval is going to be an array of tuples basically, and then here we're going to start from 0 going up to nums.length, each do num id x. Do we need access to num id x? I'm actually not certain that we do, so let's just say do each num. What we'll say is we'll start the array with num sub 0. Can num sub 0 be empty? It can. In that case, return empty array if nums.length equals 0. We say intervals is equal to num sub 0, which means we want to skip. We'll start at 1. Go up to nums.length, num x. We'll say num is equal to num sub num idx. And we'll say if the previous interval, this number is going to be equal to intervals sub the last element in intervals sub the last element in the array. Okay, so this is working, and we're gonna say if prev num is equal to num sub num index +1. So if it adds to the interval, right, then we want to do intervals sub -1 dot push I have two cases. If intervals dot length, if intervals sub -1 dot length equals 1, then we'll just do intervals sub -1 dot push num sub num idx. Otherwise, what we want to do is replace the number there. So we'll say intervals sub -1 is equal to num sub num idx. Then we'll end. Now, if it doesn't equal num sub num idx +1, I have 1 minute, and I have to go. Rip. We can finish this one though.